Welcome to my network, my LAN network to be exact. A network is a group of devices that share common communications over digital interconnections for the purpose of sharing resources via network nodes, which are devices connected in the network. LAN stands for Local Area Network. Its first commercial debut was in the 1970s by Bob McElf, and it is a collection of many devices connected together physically within a limited area. These can range from small residential networks to large enterprises like an office or school. The one I'm standing behind is only a residential LAN, but all LAN networks have a similar basis. Let's dive in. A LAN is a type of network, so how is it connected? Most networks need to have an arrangement, and this is called a topology, how computer systems are connected to each other. There are different types of topology, and these include bus, ring, and star. But star topology has become the dominant physical topology for LANs. The star was first popularized by ArcNet and later adopted by Ethernet. The star topology's main advantage is that if one node malfunctions, it won't affect the rest of the network. Unlike a serial layout like line topology, in a star topology configuration, every node connects to a central networking device, like a bike wheel. The center is like the central device, and the computers sit around it connected like the spokes. But what type of cables are used to create this stellar connection? Networking cables and networking hardware are used to connect other network devices or nodes. Generally, in a star topology setup, cables varying from coaxial, optic fiber to UTP wire can be used. Let's start with optic fiber. The optic fiber itself is a very thin strand of plastic or glass that is used to transmit messages via the speed of light. These strands are bundled together in a protective jacket or sheath, and it is actually the whole assembly of the optic fibers and the other parts inside the sheath which constitutes an optic fiber cable. The only catch of optic fiber cables is that they're pretty pricey. Traveling at the speed of light isn't cheap. For example, installation of optic fiber for telecommunications in an entire building would cost an estimated $15,000 to $30,000 for a building with 100 to 200 drops. Unlike the optic fiber cables boast on light speed, coaxial cables are used as transmission lines for radio frequency, video and data signals. Coaxial cables consist of an inner conductor surrounded by a concentric conducting shield, with the two separated by insulating material. Many also have a protective outer sheath or jacket. We can see coaxial cables also being commonly used in cable operators, telephone companies and internet providers around the world to convey data, video and voice communications to customers. Finally, UTP, which is unshielded twisted pair cable, is another type of cable which LANs tend to use. UTP cables are made up of 4 twisted pairs of copper wires enclosed by a protective plastic cover, with the greater number of pairs corresponding to more bandwidth, which is the rate of data transfer. The 2 individual wires in a single pair are twisted around each other, and then the pairs are twisted around each other as well. As well as LANs, UTP cables are also commonly used in surveillance cameras. So, in summary, we've seen that cables and topologies are what constitute networks like LAN. And there is so much more to learn, but we'll save that for another time. Thanks for tuning into my network. Until then,